Hi everyone, let's go ahead and get started on this review. You will find that I put some notes off to the side. You are allowed to make a note card for this test. Just make sure that there are no actual worked out examples on the note card. All right, so first one, number one, we are going to evaluate. Know that there's a difference between evaluating and solving. Evaluating does not have an equal sign. We're just rewriting it in a decimal form. Solving means that we have to actually solve for x. We'll still get a decimal answer, but we've got to find out the value of x. So on this one here to evaluate, we are going to do the change of base formula, which is log of 107 divided by log of 4. Now, depending on your calculator, you might have to put in 107 log divided by 4 log, or it may just work for you in this case. We are also rounding to the 10,000ths place, so that is 4 places after the decimal. So when we get this, our answer, again, you should be plugging this into your calculator just to make sure that you get this correctly. This one here is 3 and 3,707 10,000ths. Okay, so again, make sure that it is 4 places after the decimal. All right, so for number 2, what we are going to be doing on this one is we are going to go ahead and solve this one. So before I can solve it, I need to get the base and the exponent by itself. So this is a positive 7 here, so I'm going to go ahead and subtract that from both sides. So I will have 4 to the power of 3x minus 1 equals 23. Now, I need to change this into a log so that I can get that variable out of the exponent. So when we convert it to a log, I'm going to have log base 4 of 23 is equal to 3x minus 1. Okay. Now, with this log 4 of 23 here, I'm going to go ahead and convert that using the change of base formula. Again, rounding to the 10,000ths place, that's 4 decimal places, or 4 places after the decimal. Okay, so we are going to do log of 23 divided by log of 4, and we will get 2.2618 10,000ths is equal to 3x minus 1. Now adding 1 to both sides, I will get 3 and 2,618 10,000ths is equal to 3x. Okay, so now that we have that, the last step is to divide by 3. This is where we are actually solving for x, so that we will get x is equal to 1.0873, okay, or 1 and 873 10,000ths. All right, so that is that next one for number 2. So you've got to convert that exponential into a log so that we can get that variable out of the exponent. Okay, so the next one that we are going to do here is solving a rational expression. Solving a rational expression, first we need to find that common denominator, which in this case is 4x. Now we're going to take that common denominator and we're going to multiply it to everything in every numerator. So there's 3 fractions here, and because it's an equation, whatever we do to one part, we have to do to the other. So I'm going to multiply this first term by 4x, this second term by 4x, and this third term by 4x. Okay. In this first fraction, the 4's cancel out. I have x times x gives me x squared. Then here, the x's cancel out. So I have negative 7 times 4 gives me negative 28. And then here, the 4's cancel out. So I'm left with 3x. Now I see an x squared, which tells me this is a quadratic. So when it's a quadratic, we've got to move everything to one side and go ahead and solve with factoring. So I'm going to have x squared minus 3x minus 28. This is in standard form, or some of you guys remember, from tallest to shortest. Okay, so if I'm looking at factoring, I'm first going to try to use the diamond method before I consider using the quadratic formula. So on this one here, the c value goes on top, so that's negative 28, and the b value goes on bottom, which is negative 3. Two numbers that multiply to negative 28 and add to negative 3 would be 4 and negative 7. Those two there become my factors, so that I have x plus 4 and x minus 7. Now, because it said solve, I've got to get what x equals. So if I was to set each of those factors equal to 0, I would get x equals -4, and I would get x equals +7. So those are my two possible solutions. Pay really careful attention though. Just make sure it's not asking you to find the positive solution or the negative solution. In this case, it just said to solve, so I would want both solutions. All right, so number 4, which of the following represents an exponential decay? So when you're looking for an exponential decay, first off, we need to make sure it's an exponential form, which is right here. Let me grab a highlighter so I can highlight something that I wrote here. Y equals b to the x. Okay, that's exponential form. So if it's an exponential form, then if the b value is greater than 1, then it's growth. If the b value is between 0 and 1, it's a decay. Okay? So first off, this first one, 5x plus 4. Although it has an x, it is not exponential because that x is not in the exponent. That's actually a linear equation. B, this one has x to the 5th power, but the 5 that's in the exponent is not a variable, so that one is not exponential. This next one, y equals 5 to the x. This x is in the exponent, so this is exponential. So now I've got to look at the b value. B is greater than 1, so this one would want a growth, and we're looking for a decay. So it won't be C. So the next one is D. It is also exponential because the variable is in the exponent, and it has a b value of 1/5, and 1/5 is between 0 and 1. That one is a decay. Okay. All right, so let's go on to number 5. On number 5, I put some notes over to the side on the sticky note. So pay attention just to the ones on the sticky note for the horizontal asymptote. Now we're going to have a polynomial in the numerator and in the denominator. What we're looking for in each of those polynomials is we're looking for the one with the largest degree if they were in standard form. So like here, this would be m, here would be n. Imagine those are values. Let's just say that they are the leading term in each of the polynomials in the numerator and denominator. Now, just looking at the m and the n, if the m and the n are equal, then we would use the coefficients out front as our horizontal asymptote. Okay? If the m is greater than n, then the horizontal asymptote is y equals 0. And if n is greater than m, then there is no horizontal asymptote. Okay? All right, so let's look at this one here. Given this equation, what is the horizontal asymptote? Excuse me. So on this one, and I feel like I had a different equation on the paper that you guys had, so give me 1 second. Nope, that's it. Sorry guys, I have a couple different reviews in front of me. We had a different problem, so I'm going to go ahead and change this. So give me 1 second here while I black this out. Sorry about that, guys. I had a different one on your guys' review. Some of you might have picked up the review that I actually have this one here. So do me a favor and please change this problem with me. Okay. So this one here should be y equals, oops, that's not what I want. Y equals x plus 1 over x minus 5. Okay, so on this one here, for our horizontal asymptote, the two pieces that we are going to be using is these two terms right here. Okay. Now, since they both have an exponent of 1, the exponents are equal. So we're going to use the values of the coefficient. Well, what number is in front of x in the numerator? Well, that's just 1. What number is in front of the coefficient in the denominator? That's also 1. So our horizontal asymptote is where y equals 1. Okay? All right, so what is the vertical asymptote? Well, the vertical asymptote is only relating to the denominator. Okay? Sorry. So this one here was y equals 1. So if it's only relating to the denominator, all I'm going to look at is this piece here. So to find the vertical asymptote, I set the denominator equal to 0 and solve it. So if I have x minus 5 equals 0, then we get that the vertical asymptote is where x equals positive 5. Okay? All right, solving the log equation. Now it's a log. So when it's log, as long as there's nothing in front of the log, I can go ahead and rewrite it as exponential. Earlier, we took an exponential and wrote it as a log. So on this one, our base is 5. And then the 7x minus 3 and the 4 are going to swap places. And this word log is going to fall off here. So we are going to have 5 to the 4th power is equal to 7x minus 3. Okay? So that's that first piece where we've taken that actual number and we've gone ahead, or that value, and we've converted it into exponential. 5 to the 4th power is 625 is equal to 7x minus 3. Add 3 to each side. So we have 628 is equal to 7x. All right. Now at that point, what we're going to do is just this last step is we're going to take 628 and divide it by 7, and we get x is equal to 89, and I'm going to go with 71 hundredths. Okay. All right, that is for number 7. It didn't say 4 decimal places. If you did 4 decimal places, I would make sure that I understood that too. When in doubt, just do 4 decimal places. Right? Okay, so let's go on to this next one. So this next one, we're going to work on condensing logs. So we had condensing and we had expanding. So a couple of clues about condensing. Remember that what we're trying to do is get all the logs together into one. However, if there is a coefficient in front of the word log, like this 4 in front of log here, we need to move it to go as the exponent on top of that argument. Okay, so first thing we're going to do is we're going to rewrite this so that it's log a to the 4th. Remember, there is a base. It's a base of 10. We just don't write it. Minus log b to the 7th minus log c squared. Now that there is no coefficient in front of all the logs, if they're a positive log, they're placed in the numerator. If it's a negative, it's going to be placed in the denominator. That log base 10 is going to go out front. Okay. A to the 4th is going to go in the numerator. B to the 7th is going to go in the denominator. And C squared is going to go in the denominator. That there is our solution. Okay. All right, for this next one, if $35 is deposited into an account paying a 1.2% compounded continuously, find the balance in the account after 20 years. So we are going to use A equals PERT. E is because it is continuously. So whenever we say something that is continuously, we need that A PERT. Okay. A is the future amount that we want to have, and we don't know that yet. So we're just going to have A equals. P is the principal amount, the amount that we started with. So we started with $35,000. E is an actual number, so we're going to keep that here. R is the rate written as a percent. So 1.2, we move the decimal place to this way, or I'm sorry, multiply it by, or divide it by 100 so that we get 0.012 as a decimal. So 35,000 times E, 0.012 or 0 and 12 thousandths times t, the number of years, which is 20. Okay. So let's go ahead and calculate this. So it's 35,000 e to the power of, well, let me do that one, make sure I don't mess that up. 0.12 times 20 is to the power of 2.4. Okay, now on this piece, we need to do the exponents first. Okay, so we're going to do e to the power of 2.4. Now there is an e in your calculator, even the one on your phone. It is towards the bottom right above the pi symbol. Okay, for the exponent on your phone, it is going to be one that says e to the x. I'm sorry, nope. Let's try that again. So we're going to put in e, and then we're going to put in the xy button. It's under the m plus. X to the power of y, and we're going to put in 2.4. So then I get a is equal to 35,000 times 11 and 231 ten thousandths. So multiply that together, and the amount that we will have in 20 years is 385,811 and 17 cents. Okay. All right, so let's go to problem number 10. On problem number 10, we are going to be solving for x squared. Okay, remember that we cannot take the square root of a negative number, but we have to remember how to simplify radicals. So on this one here, what we're going to do is we're going to take x squared, and we have to square root it to get rid of that square. So whatever we do to one side, we do to the other. So we have x squared is equal to negative, not negative, to I radical 24. Okay, a negative can come out as an I. It's an imaginary number. Now we've got to factor 24. We've got to look for all the values that would multiply it, okay, and see if there's any perfect squares. So 1 and 24, which neither is a perfect square. 2 and 12, which neither is a perfect square. 3 and 8, which neither of those is a perfect square. And then I have 4 and 6, and 4 is a perfect square. So the square root of 4 is 2. And you know what I forgot to do here is I forgot to get rid of this 2 here. I don't need it, because once we take the square of both sides, that gets rid of that. So we will have x is equal to, square root of 4 is 2 times I, and what's left underneath is 6. Okay. Now remember the last piece that I said, whenever we take the square root, we always have to put a plus or minus up front. So I'm going to rewrite that. X is equal to plus or minus 2I radical 6. Okay. All right, so on this next one for number 11, since it's not factorable using the x to negative 3 and 2, we're going to go ahead and use the quadratic formula. So our a value on this one is 2, our b value is negative 3, and our c value is 2. So we have x is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 2 all over 2 times a, which is 2. So negative 3 is positive 3 plus or minus. I'm going to take this out and do it here. Negative 3 squared is 9 minus 4 times 2 is 18. Sorry, 16. I'm thinking ahead. 4 times 2 is 8. 8 times 2 is 16. So now I have 9 minus 16. So 9 minus 16 gives me negative 7 all over 4. Okay. Now again, I cannot take the square root of a negative number, but I can take out an I so that we will have x is equal to 3 plus or minus I radical 7 divided by 4. Okay. All right, on this next one, we are going to solve this square root problem. So how do we get rid of a square root? In order to get rid of a square root, we square both sides of the equation. So I'm going to go ahead and square this side, and I'm going to square this side. So on this side, we are left with x minus 6, and over here, we have x minus 8 times x minus 8. So we've got x minus 6 is equal to x squared, negative 8x, negative 8x plus 64. Combine these two. Then we're going to move everything over to the other side, so it's set equal to 0. So I'm going to have x squared, subtract this x from both sides, so that gives me negative 17x, add 6 to both sides, and that gives me positive 70. All right, I want to see if I can find two numbers that multiply to 70 that add to negative 17, and that would be negative 7 and negative 10. So I would have x minus 7 and x minus 10. It said to solve it, so we get x equals positive 7 and x equals positive 10. Okay. All right, I'm going to pause this video here, and I'll go on to the second video and finish the second half of this.